now let's start looking at the equation for current. Let's get familiar with the symbols and the units for the various parts of the equation. So if you remember the definition for current, all right, we said that current is defined as the charge which passes by a given point, and I'll add to that in a circuit, right, in a certain amount of time. And that amount of time is generally going to be per second, right, per 1 second. All right, now, the symbol for current is capital I. The symbol for charge is lowercase q, and the symbol for time, you know, is a lowercase t. The unit for current, you remember from earlier in this video, is coulombs per second, all right? But we know that a coulomb per second is also known as an ampere, all right, or amp, and the symbol for amp is capital A, all right? So coulombs per second are called amperes. Some people call them amps, and the symbol for that unit would be the capital letter A. The unit of charge is the coulomb, and the unit of time is the second. All right? Now, let's see where coulombs per second comes from. All right, let's just take a moment and see where exactly that unit comes from. The current equation, all right, the current equation would be, all right, current is the amount of charge per time. All right, so if current is an amount of charge per time, all right, that passes by a given point in a certain amount of time, then you can figure out the unit from the equation. All right, what's the unit for charge? The unit for charge is the coulomb. The unit for time is the second. So that's why, if you look at the equation, all right, the unit for time is the coulomb per second. Coulomb per second. And again, a coulomb per second is also called an ampere. People call them amps. All right, amp or amps. And we symbolize that unit with a capital A. All right, now, I also want to mention conversions from amperes to smaller units and conversions from coulombs to smaller units. All right? Now, perhaps we all know that milli is a metric prefix that means, all right, 1,000th, or 10 to the negative 3, right? Or, if you like, 0.001. All right, so if we have a 1 ampere, all right, 1,000th of an ampere, all right, 1,000th of an ampere would be a milli, would be 1, I should put the number 1 there, would be 1 milli ampere. All right, 1,000th of an ampere would be 1 milliampere. Or you could say there are, all right, in 1 ampere, there are 1,000 little itty-bitty milliamperes. Now, we really don't want to use a capital there. I put the capital there for emphasis. It's really all lowercase letters. All right? So 1 big giant ampere would be 1,000 little milliamperes. Just like 1 meter would be 1,000 millimeters. Right? The milli means 1,000th. So there are 1,000 little guys in 1 big guy. All right, now what if we wanted to convert, all right, from amperes to milliamperes or milliamperes to amperes? If you're given milliamperes, you're probably going to have to convert to amperes. All right, so let's see how to go back and forth between amps and milliamps. All right, keep in mind here that 1 ampere is 1,000 milliamperes. we'll use this equality, all right? This is called an equality, all right? We'll use this equality in the factor label method to convert from amps to milliamps and vice versa, all right? So for example, all right, let me grab my little paper here. Okay, let's convert 5,000 milliamperes. Right? If I have 5,000 milliamperes, and I want to know how many amperes that is, right? I put a big set of parentheses and a line. Right? See, this is really over 1. All right? That's why I have a top numerator, denominator. This is in the numerator. The denominator is obviously over 1. We don't have to put that there. All right? Now, you take your equality. Your equality is 1 ampere equals 1,000 milliamperes. All right, so I want to get rid of milliamps. So I put the milliamps down here. These are going to cancel. I want to get rid of the milliamps. I want amps. The best thing with the factor label method is probably to put your units in first correctly. Then put your numbers with the correct units. 1 amp, right, 1 amp is 1,000 milliamps. Now, 5,000 divided by 1,000. See how this is on the bottom? You can't cross multiply. The equal sign is over here. This is not a situation where you cross multiply. No, no, no. Okay? This is 5,000 divided by, here, 5,000 times 1, right? But we don't care about that. It doesn't change anything. 5,000 times 1 and then divided by 1,000. So it's really 5,000 divided by 1,000. That's going to be 5 amps. All right, so 5,000 milliamps equals 5 amps. Take the 5,000, divide by 1,000. All right, let's try one more. All right, what if we wanted to convert, all right, what if we wanted to convert 60 amperes, all right, 60 amperes to milliamperes? All right, I want to get rid of amps. I want milliamps. Right? Now watch, 1 amp, right, equals 1,000 milliamps. Remember, top and bottom inside the parentheses have to equal each other. All right, so 60 times 1,000 is 60,000 milliamps. Okay? Now, you can do the same thing with coulombs, all right, and millicoulombs. Or how about microcoulombs? All right, micro would be 10 to the negative 6. All right, that's 1 millionth. All right, we'll just 1. Right? Okay. Micro is 10 to the negative 6, so 1 millionth. Okay. So that means, for example, that 1 coulomb equals 1 million microcoulombs. All right, that's micro. Okay, that is the symbol for micro. That's the same letter mu. All right, that's the Greek letter mu. Okay, it's kind of like a U, with a tail in the front. So I usually just start low, swing up, and make a U. Start low, swing up, and make a U. That's my mu. Okay. So if 1 coulomb is 1,000 1 million microcoulombs, then what if I have 0.003 coulombs? All right, I want to convert that to microcoulombs. All right, so I take coulombs, I want microcoulombs. Okay, 1 coulomb equals 1 million microcoulombs. So I take my 0.003, multiply by 1 million. All right. Okay, and I get 3,000 microcoulombs. Okay, one more quick little conversion. All right. How about millicoulombs? All right, instead of microcoulombs. All right, 1 coulomb would be 1,000 millicoulombs, right? The same way as when we did amperes. All right, so what if I had 200 millicoulombs? Okay, how many coulombs would that be? All right, I want to get rid of the millicoulombs. I want coulombs. One big giant coulomb is 1,000 little millicoulombs. Remember, the M is milli. The same milli that's in millimeter. All right, 1 meter would be 1,000 millimeters. So 1 coulomb is 1,000 millicoulombs. All right, 200 divided by 1,000. All right, now you can do this the easy way. 200, there's your decimal point. To divide by 1,000, multiply, move 3 places to the left. 1, 2, 3. All right, or pick up your calculator and do 200 divided by 1,000. All right, the answer is 0.200 coulombs. Okay, so that's just a little bit about converting between amperes, milliamperes, coulombs, millicoulombs, microcoulombs. Microamperes would be 10 to the negative 6, or a million per ampere also. All right, remember, milli means 1,000, all right, or 1,000th, and micro means 1/1,000,000th, so there are a million of them. All right, now, next, we're going to take the equation, all right, the current equation, okay, and what we're going to do, write the current equation, okay, symbols, okay, all right, the current equation, use the words, okay, so, first of all, current, right, is equal to charge divided by time. Those are the words, right? Now, if we do it with symbols, okay, current is equal to charge divided by time. Okay? This is words, those are symbols. Now, we want to be able to solve for, right now we're solved for charge, so here's charge by itself. But what if they're asked, I'm sorry, this is current by itself. This is solved for current. Solved for current. So the current is by itself. What if they asked us to solve for charge? We'd need the Q, the charge, to be by itself on the left side. All right, so let's do that. All right, so if current is charge per time, if I want charge by itself, I'm going to put the current over 1, and then I'm going to cross multiply. Charge times 1, right, equals current times time. Current times time. So there's the equation if I want charge. Get the charge by itself on the left side. Now, what if I want the time? What if I want to know how much time? All right, I got to get the time by itself on the left side. Now, these are inversely related. You are allowed to just switch them, right? Switch the T with the I. It's perfectly mathematically correct. If you put the T here and put the I on the bottom, then T is equal to Q divided by I. All right, so we have 3 versions of this equation. All right, we've got the current equation, okay? You get rid of that. Now, we've got the current equation solved for current. All right, I equals Q divided by T. We've got the current equation solved for charge. Q equals I times T, and we've got the current equation solved for time. Switch these two. All right, time equals Q divided by I. All right, I mean, there are other ways you could get the T over here by itself. You could multiply both sides by T and then divide by I. All right, if I were to multiply both sides by T, right, cross that out, then get IT equals Q. All right, and then divide both sides by I. All right, and so ultimately we're getting, boop, boop, all right, T equals Q divided by I is what we ultimately get. But isn't it a lot quicker, all right, isn't it a lot quicker to just switch the T and the I than to go through all those steps, okay? So there are other ways to do that, but switching the inverses, right? These two are inversely related. Switching inverses is the quickest way to get that T by itself, okay? All right, now, let's do some problems. Okay, copy this question. All right, pause the video, copy down this question, or you can just print out the worksheet that already has the question copied down. The first problem, calculate the current, all right, flowing through a resistor if 12 coulombs pass by in 3 seconds. All right, so given, okay, 12 coulombs, so Q is 12 coulombs. All right, the time is 3 seconds. We're being asked to find, all right, the current, I equals, all right, how many coulombs per second? How many coulombs per second is that, okay? Given charge and time, find the current. All right, the formula that would work in this case, all right, is going to be I equals Q over T. All right, so we plug in 12 coulombs, we plug in 3 seconds, all right, and we get that I is 12 divided by 3, or 4, and look at the unit, coulombs per second, 4 coulombs per second. You could write I equals 4 amps, all right? You could do that. All right, let's do another problem. This time we're going to try to find charge. Okay, copy down this question. We'll be starting the question in just a minute. You can pause the video and copy the question, or just print out the worksheet and you'll have a copy of the question. Okay, so this next problem reads, calculate the charge. All right, so given, don't know yet, find. All right, it says calculate the charge. So they're asking us to find the charge. So Q in coulombs is what we're trying to find. Calculate the charge flowing through a section of wire in 4.6 minutes. So the time is 4.6 minutes. Now we're going to have to change that right away to seconds. All right? If the current is 3 amps, so the current I is 3 amps. All right? So let's right away change the time from minutes to seconds. All right, let's do that right away. Okay, so 4.6 minutes. All right, we'll use the factor label method. I want to get rid of minutes, so I put minutes on the bottom. Here's my equal sign over there. I want seconds. All right, so these have to equal each other inside the parentheses. 1 minute equals 60 seconds. All right, so 4.6 times 60. All right, 4.6 times 60, we've got 276 seconds. 276 seconds is what we have for time. All right, so let's just go ahead and change that. This is now 276 seconds instead of 4.6 minutes. 276 seconds. All right, now we need to pick a formula. We have current and time. We're trying to find charge. So the formula that would make the most sense, all right, would be, all right, I equals Q over T, but since we're trying to find Q, we will cross multiply. Q times 1 equals I times T. All right, whatever you're trying to find should be by itself on the left side. So we're going to use this version of the equation. Q equals I times T. All right, Q equals I times T. Now, we might as well use, instead of amps, we'll use coulombs per second. I'll show you why in just a minute. So 3 coulombs per second. The time is 276 seconds. Now you know that those seconds are over 1. So you see seconds on top, seconds on the bottom. The seconds cancel. The correct unit for the answer is coulombs. So Q equals 3 times 276. All right, 276, 828. All right, coulombs. Okay, very simple. Okay, copy the practice question. All right, pause it, copy it, and we'll start in just a moment. All right, this problem reads, calculate the amount of time. All right, so, given, we don't know yet, but we're being asked to find the amount of time. All right, that would be in seconds. Calculate the amount of time it takes for 0.4 coulombs. Now, coulombs is charge. All right, that's 0.4 coulombs to pass through a point in a wire if the current is 600 milliamps. If the current is 600 milliamps. The first thing we have to do is change milliamps to amps. All right, so we have 600 milliamps. All right, let's change that to amps. All right, I want to get rid of milliamps. This is milliamps on top, so I should put milliamps on the bottom, amps on top. Okay, one big giant amp is equal to 1,000 little bitty milliamps. So we're going to take 600, divide by 1,000. 600 divided by 1,000, all right, is 0.6 amps. Okay, you could just, you know the decimal point is there. Dividing by 1,000 is 1, 2, 3 jumps to the left. So you can either use your calculator or use what you know about decimal places that are to the tenths, right, tens and tenths. All right, 600 amps. Okay, so let's replace 600 milliamps with 0.600 amps. Okay? And now let's solve our problem. We're being asked to find time. They gave us charge and current. So the formula that makes the most sense is the formula for the definition of current, right? I equals Q over T. Now, you know that you are allowed to switch inverses. The I and the T are inversely related. You can switch them. All right, put the T up there, put the I down there, and you get T equals Q over I. This is the equation we'll be using because we're trying to find time. What you're trying to find should be by itself on the left side. All right, that's correct mathematics, and correct mathematics is correct physics, because physics is all about math. All right, T equals Q over I. All right, and here we go. All right, the Q is 0.400 coulombs. The charge is 0.600 amps. That's coulombs per second, right? An amp is a coulomb per second. All right, so the time is 0.4 divided by 0.6. All right, 0.4 divided by 0.6 is 0.667. Okay, 0.667. Now, let's look at the unit. Okay, I'm going to take this down here. I'm going to invert and multiply bottom and top. So I'm going to invert seconds per coulomb, seconds per coulomb. Oh, that's a lousy little C there. Seconds per coulomb, all right? Coulombs and coulombs cancel, seconds and seconds cancel. All the units are canceled on the bottom. Coulombs on top, coulombs on the bottom, cancel. The correct unit is seconds. But we knew that anyway because it's time. So the correct unit has to be seconds. All right, so that's that problem. No big deal. Moving on to a problem where we're being given electrons, number of electrons, instead of coulombs at the beginning. So we're going to have to convert at the beginning the number of electrons that we're given to coulombs. All right, now take a look at this question. What is the current in milliamperes? All right, so they're still trying to figure out the current, but they'd like it in milliamperes. Now we can get amperes first and then convert to milliamperes. All right, given, all right, find, we're trying to find the current, all right, and I'll do it in amperes and then we'll convert to milliamperes later, right? If 2.5 times 10 to the 19th electrons. Now we know to find current, we're going to need to know the charge, but they're giving us the number of electrons instead. So we're going to have to convert the number of electrons to coulombs before we get started. All right, so we're being given, all right, let's just say N, all right, the number of electrons. All right, N is a good symbol for number of electrons. All right, see if we can find a better marker here. Given N equals 2.5 times 10 to the 19th electrons, all right, and 3 minutes. Now the time, all right, is 3 minutes. All right, so what you see right away is to get the current, you're going to have to change the number of electrons to Q, or charge, and you're going to have to change the time from minutes to seconds. All right, so let's get to work on that to solve this problem. All right, copy this all down, okay? And here we go, okay? All right, so let's convert 2.5 times 10 to the 19th electrons to coulombs, all right? 2.5 times 10 to the 19th electrons, all right? Now, do you recall from the beginning of this video, you should probably memorize this, it is on your reference tables, okay, that 1 coulomb is 6.25 times 10 to the 18th electrons. Do you remember that? All right, so what you can do is you want to get rid of electrons, all right? You want coulombs, all right? So, and there we go. 1 coulomb is equal to this many, all right, electrons. So we're going to take this number, divide by this number to get the charge in coulombs, which is what we need to calculate current. All right, so pick up the calculator, 2.5 exponent 19 divided by 6.25 exponent 18 equals 4. Okay, so this is 4 coulombs. Well, that's a nice number. All right, so we've got 4 coulombs. All right, and we also had to convert 3 minutes, okay, to seconds. All right, so 3 minutes, all right, minutes, seconds, okay. 1 minute equals 60 seconds, so 3 times 60 is 180 seconds. Okay, now we're ready to plug into the current equation. We're trying to find current. I equals. Okay, so here we go. All right. All right. Current equals, all right, charge divided by time. That's coulombs divided by seconds. Okay, we'll do it across. Here we go. It was 4 coulombs divided by 180 seconds. All right, 4 divided by 180 equals 0.022 coulombs per second. So that's 0.022 amps. all right, amperes. But they asked for milliamps. So we want to get rid of the amps. We want milliamps. All right, 1 amp equals 1,000 little bitty milliamps. 0.022 times 1,000. You know you just move the decimal place 1, 2, 3 places to the right. So that's going to be 22, all right, 22 milliamps. It's 22.2, but let's just do 22 milliamps. Okay, so 22 milliamps is the current when we work out this problem. Okay? Now here we have a question where they'd like to know how many electrons flow through a resistor in 2 hours. Now you know right away you're going to have to convert 2 hours to seconds. Okay? If the current is 5 milliamps. So they're giving you, let's see what we're being given. Okay? And what are we being asked to find? All right, how many electrons? They want to know N. They want to know how many electrons. All right, now, if we know the charge flowing through, if we can find Q, right, in coulombs, we can convert coulombs to electrons. You see right away they're talking about current and time. So you know you can use that equation I equals Q over T. If you can get the charge in coulombs, you can convert that and that to a number of electrons very easily. So we want to find how many electrons. So we're going to find the charge to convert that to how many electrons. 2 hours, all right, so the time is 2 hours, all right, 2H, and the current I, all right, is 5 milliamps. Now you know you're going to have to convert 2 hours to seconds. You're going to have to convert milliamps to amps. Okay? So let's get started, and then we'll pick a formula. I mean, I think the formula we're going to need is Q equals. We're trying to find Q so we can get the electrons. All right? We can find Q and convert that to electrons very easily. So I think the equation, I'll just put down the formula that I think we're going to use. Because we're trying to find Q, we have T and I. It's going to be Q equals I times T is going to be our formula. But we have to convert current to amps from milliamps, and we have to convert time to seconds because we were given hours. All right, so let's get on this. All right, let's do our conversions first. All right, we were given I equals, let's see, 5 milliamps. 5 milliamps. Let's convert that to amps. Milliamps to amps. One big giant amp is 1,000 little milliamps. All right, so we're dividing by 1,000. This goes 1, 2, 3 jumps to the left. 1, 2, 3 jumps to the left. So we're getting 0.005 amps. Okay, so we're going to use that. And 2 hours. All right, now either you know that 1 hour is 3,600 seconds. All right, if you already know that, then you know that this is 7,200 seconds. Okay, if you know that 1 hour equals 3,600 seconds. Or if you don't know that, if you don't have the 3,600 memorized, then maybe you want to do hours to minutes. 1 hour equals 60 minutes. Now that we have minutes, we convert minutes to seconds, right? 1 minute equals 60 seconds. And 2 times 60 times 60, all right? 2 times 60 times 60 gives us 7,200 seconds. All right, so either you convert hours straight to seconds, or you convert hours to minutes and then minutes to seconds. Either way, you're getting 7,200 seconds. All right, so here we go. Okay? Here we go. All right. So, the charge is going to be the current times the time. The current was 0.005 amps. All right, the time was 7,200 seconds. All right, now I tell you what, instead of amps, let's put coulombs per second. We know this second here is over 1. The seconds are going to cancel. All right, so the charge that flows through this resistor in 2 hours, all right, is going to be 0.005 times 7,200. So that's 36 coulombs. All right, now, they want to know how many electrons is that? Well, we can convert coulombs or charge to electrons. There's actually 2 ways you could do that. There's actually 2 ways. All right, 36 coulombs. Now, we know that 1 coulomb is this many electrons. All right, electrons. Let's do it that way first. 36 times 6.25 to the 18th. So that's 2.25 times 10 to the 20th electrons. Now, there is another way you could do this. 36 coulombs. All right. We also know, oh, my markers are running out. We also know, let's try this one. We also know, that's worse. That's worse. How about this one? Oh, there we go. All right. We also know that 1 electron, right, has 1.6 times 10 to the negative 19 coulombs. Now, while we're at it, all right, if it's electrons, it's a negative charge, all right, and if it's an electron, he's got a negative charge. Those negatives are going to cancel anyway, just technical point there, all right? But let's take 36 and divide it by this number and see what we get. You think we're going to get that? We should, right? 36 divided by 1.6 to the negative 19. Oh, got the same answer. All right? 2.25 times 10 to the 20th electrons. Okay? Because we know that 1 coulomb equals this many electrons. So we can use that equality. It's perfectly correct. We also know that 1 electron has this many coulombs. I'll make it negative, all right? 1 electron has this many coulombs. So either this equality or this equality is going to get you the right answer, converting coulombs to electrons. Okay? So just keep in mind, all right? If there is a question where they're talking about current and time, and they're asking about the number of electrons, you're going to have to go through charge. If they give you the number of electrons, convert it to charge before you put it into the current equation. I equals Q, charge, divided by time. If they're asking you for electrons, get the charge first, and then convert it to number of electrons. All right? So this has been our little video on current, okay? And I want you to picture, when you picture current, all right, I want you to picture 1 coulomb of electrons as a little dot flowing around the circuit. All right, picture that for now. And that way, when we start talking about voltage and resistance and everything else, you're not going to get confused. You're going to have a solid picture in your mind about what current means and how it's different from voltage and all the other electrical parameters that we're going to study.